Greetings again, this is Panu from VLSI. Today I'm going to show you how to get a list of drives and files under the VSOS. I have here a VS1005 developer board. Let me just reset it with the S1 button pressed. We can see that inside we have some drivers, sd.dl3, and in the config.sys we have the instructions to load the sd driver and for drive letter D. And the kernel in this developer board is normal 3.09 VSOS for the SPI flash. Okay, so there is nothing else on the flash, so let's get started. First, let's start VSIDE and make a new solution. We'll make a VSOS 3 application and we will call this one init. Oh, I have made it already. Okay, let's do it init 2. And take hello world application. Okay, and then let's rename this project to init. A project named init creates the file init.ap3, and init.ap3 is the first program that the kernel tries to run after loading the kernel. So we just try to make something that runs after we boot. So now it says printf hello world, and in the end let's write while one do nothing. That's it, and it doesn't return anything, so let's do it like this. Build solution, it builds, and I have set the target drive here. Let's set it again. This removable drive F is the flash of the developer board. Okay. And so now when we have rebuilt this, it copies the program into F as init.ap3. Let's take a look at it once again. Init.ap3. It's here in the removable disk. So let's try to run it. We have not loaded any console drivers, so all the console output goes to the UART. And if I reset the board, we can see that it runs. It loads the SDSD driver. First the SDisk is SPI flash, and then the new driver SDSD creates the SD card as drive D. And the kernel boots, and then it tries to load init.ap3, which prints hello world as we have written here. Okay. First of all, let's try to get a list of disk drives in the VSOS. So let's write here hello world. And instead of hello world, let's say list of drives. List of drives, sorry. My Finnish pronunciation is not that elegant. Okay, so let's make here an integer, and there's 26 letters in the English alphabet, so let's make a for loop. And let's try all the devices from A to Z. Let's here make if VOP devices I. Now there are 26 device letters in the VSOS from A to Z, And the pointers to the device structures are in this array called VOP devices. So if VOP devices I is on0 and VOP devices I arrow file system equals VO file systems 0, which is FAT file system always. Then let's printf found FAT device character, and the character would be A plus I. So we are running I from 0 to 25. So A plus 0 is A plus 1 is B, and so forth. Let's try to run this one. Build this solution, reset the developer board so that we get the disk F, the flash, and rebuild. It is copied as init.ap3, and let's run termite and restart. And here it runs the list of drives, and it says found FAT device D, found FAT device S. So it tries to detect all the devices whose file system is FAT, which is guaranteed to be VO file system's first entry, so VO file systems 0. Okay, and let's see, we can try to identify what that is. And let's put one more string into the printf and add VOP devices I arrow identify VOP devices I and null and 0. And let's copy this again. Sorry. Right. Build solution again. Copy it to init.ap3 and let's run once again. And now we have the identification. Device D, SD card in SD mode, so SD card. Device S, which is SPI flash C814, which is the manufacturer ID for the SPI flash. Right. So now we have found all the devices that have a FAT file system. So it's a pretty good guess that those contain some files that we maybe want to play audio or do something else with. Next, let's see how we can find those files inside those devices. It's a little bit more tricky, but not that difficult. Let's make a new scope so we can declare a new variable. First, let's get a buffer for a file name. Character file name. We get a buffer by calling malloc. And let's get 256 characters. Okay. And then if we got a buffer from malloc, we do something. Otherwise, we don't. We could put an error message here. Okay, let's write it. Cool, couldn't get a buffer for file name with malloc. Otherwise, we have got a buffer for the file name, so we can use it. Error. Upon taking a look at this video, I realized that I forgot to free the buffer got from malloc at this time. So here it should say free file name. So very, very, very important. If you get a buffer from malloc, then you must always free it, otherwise the system will soon run out of memory. Okay, so I forgot this the first time I wrote this code, so you won't see this in a minute, but you must have this free file name here if you use the malloc code here. Okay, let's get back to the video. And now here comes the tricky part. File f equals fopen Now here we need to have a drive letter. Let's say that we have S. S drive that contains, let's later make it so that it lists the drives, the files in all the drives. But now let's list the drives in files in drive S. We need to get a handle to that drive for searching files, and we get it by fopening with the mode S. S for searching. And once again, if we have the handle, then we can use it. And the last thing that we write is f close f. So if we get a handle, then in the end we must also release it. Now we have the handle to the drive, not to a file, but to the drive. And we can call now fat find first. And let's write fat find first this handle and the path again oh, nothing here, and then file name, which is the buffer where we want to get the information, and the length of the buffer, which was 256. Okay, and this actually returns whether it has found any files or made some kind of error. So let's make this inside an if and see if it's okay. And if it is okay, we will write found something, and let's try to run this. Build, rebuild. Malloc is not found, so we need to include sysmemory.h, and fat find first is not found, that's rather interesting. Let's include eofat.h. Right. So now we have compiled it and we can run it. So let's try to run it. And great, it prints found something. Okay, let's see what that something is. First thing we can see, let's write the file name, which is the buffer we have got here. Once again, build and rebuild, and always when I do this, I reset the developer board with the S1 button pressed so that we can see the contents, and the VS IDE can update this init.ap3. Run this one, reset, so it runs. It found something sys, which is rather nice. It's a folder that we know exists in drive S. Okay, but let's extend this. We want to print all the files that we find in the disk. So let's make a do while loop. Do printf found something file name, and let's see, found some strange keyboard. And after printing the information, we call find next, and let's write it here, while we find a next file. So while we keep finding files, we print the found. Once again, reset and rebuild solution, copy to init.ap3 and reset the developer board to run. So we have found sys config.txt and init.ap3 in the S disk. We can print other information besides the file name. Found file name, and let's make it a little bit more nice looking, and say short name, short name is in the file's extra info after calling fatfind first, fatfind next. Okay, let's try and run this. Build solution. Okay, sys, short name sys, config.txt, short name config.txt, init.ap3, short name init.ap3. That's nice. Let's continue. Let's make a new line here. Let's print attributes. Let's write those in hex. And this information attributes whether it's a file or directory, you know, the FAT attributes. This is another strange place where to get it. We get it from the f handles on getC buffer. Maybe it sounds like a strange place to get those informations, but the ungetC buffer is definitely not needed while we are searching for files. So it's as good a place as any to put this information in. And let's run this. We see that we get sys attribute is 10, config.txt attribute 20, init.ap3 attribute 20. So from this we know that sys is a directory. We can put here if, and let's see, from fat.h we see attribute directory. We can printf dar here. So it says it's a directory. Build solution and finished. Run this. We can see that sys is a directory and config.txt and init.ap3 are not directories. Often we are also interested in the extension of the file. For example, if we are trying to find all the MP3 files. Let's say extension, and the extension is always after the short name. So we know that the short name is 11 characters, and then there is the C0 terminated strings final 0. So always we find the extension from this location. F arrow extra info 30. Build solution. Oh, sorry. Reset to get the flash visible. Rebuild solution. Copied to the flash and reset to run. We see some mistake. Okay, sorry, my mistake. So this is a pointer. We need to get the address of 13th of extra info. Okay, let's try again. Build, rebuild solution and run again. And here we can see found file config.txt, and this one's extension is txt. Found init.ap3, this one's extension is ap3. Great. And as a final stage, let's rewrite this so that this becomes a function. And let's make this here list files, and the character would be drive letter. Okay, that's nice. And here let's make a temporary string 3 long, and here let's see, we printf s So we get a string with which we can do the fopen. And here, let's first try list files S for drive S. Build it and copy it to the flash and run it, and it lists the files in drive S. That's nice. And now let's make it like this. List files, and instead of S we say A plus I. Build, rebuild the solution, sorry, too fast, copy to the flash and run. Here we can see that the SD card has a lot of files, Utopia, free sample, MP3, this and that, and the S device, SPI flash, has the sys config.txt and init.ap3. So here we have the means to list the drives that contain files in the VSOS and list the files inside each drive. And you can scan the extension to, for example, list only MP3 files, whatever you like. But this time we are happy for this accomplishment, finding the devices and listing the files inside the devices. I'm Panu from VLSI. Thank you again for watching, and let's see you at the VSDSP forum. Bye bye.